Assalamualaikum and hi, it's me again, Miss Huda. Let's continue with example number 5, center of gravity. Find the location of the center of gravity from point P and reaction at the support at point A and B. The information given is the wall thickness 200 mm and the density of the brick wall is 1500 kg per meter cube. Let's find the center of gravity of the wall first. We have to divide the wall into a few sections because of wall ni ada macam-macam bentuk yang being combined together. The first one, I divide it like this, and the second one, the third, and the fourth. It's up to you how you feel that you rasa nak divide. You will get the same answer. Kalau you bahagi macam ni pun boleh. And then another one like this, another one like this, and the fourth one. And in this case, I divided it like this. First, we're going to calculate the area for section 1. Section 1, the area will be 3 meter width and the height will be 6 meter. This is rectangle, therefore 3 meter times 6 meter. And the distance from the x-axis. So x-axis will be here, the centroid is going to be around here, and you will need this value. It will be, this one is 6 meter divided with 2, and this one is 4 meter. Therefore, 6 meter divided with 2 plus with 4 meter to get the distance from the centroid of section 1 to x-axis. And for y bar here, it will be the distance from the centroid to the y-axis, which means this one is 3 meter divided with 2 plus with 5 meter. Okay, this will be the one. And you times the area with the x bar and you get this value. The area times with y bar, you will get this value. Next is for second section here, section 2. First, we need to find the area. It will be 5 plus 3 meter, the width, and the height width will be 3 meter plus 1 meter equal to 4 meter. Therefore, this is the area. And the x bar going to be from the distance of this section to the x-axis. Therefore, 4 meter divided with 2. And for the y bar, it will be from the centroid to the y-axis. It will be 8 meter divided with 2. And you times the area with the x bar times the area with the y bar. For section 3, it is a triangle. Therefore, the area will be half times with the width 3 meter times with the height. It is another 3 meter. And the distance from x-axis, which is the x bar, will be from the centroid to the x-axis. Therefore, this one is going to be 1 over 3 times 3 meter, and then you have another 1 meter below here. Therefore, 1 over 3 times 3 plus 1 meter. And the distance from y-axis, sebab kita nakkan y bar, this one will be 1 over 3 times 3 meter. And you have another balance here, 8 meter. 1/3 times 3 meter plus 8 meter. And get the AX bar and AY bar. Next, we have area number 4. For area number 4, this is a rectangle. The area will be 6 meter and the height is 1 meter. Therefore, 6 meter times width 1 meter. And the X bar will be half of the 1 meter here, ya, sebab distance from the centroid to the x-axis. Therefore, 1 meter divided with 2. Next, we need to find the y bar. The y bar will be the centroid to the y-axis. Up until here, this will be 6 meter divided with 2. And here will be 8 meter. 6 meter divided with 2 plus 8 meter. Then you can calculate the AX bar and AY bar and total up the AY bar and AX bar together with the area. Sorry, di sini dia bukan tolak ya, dia tambah. Because of area ni tak ada main tolak-tolak, dia tak ada hollow section di sini. Jadi kita tambah sahaja semua section yang kita divide tu. Next, we can calculate the value of X bar for the whole section. Just take the AX bar here, total, and the total area. We have the X bar is equal to total AX bar divided with total area. So 202 is the total AX bar and 60.5 is the total area. Same goes with the Y bar. Y bar will be total of AY bar divided with total area. So this one just take from your table the value of total AY bar bagi dengan total area. Then you can get the value of X bar 3.339 meter from x-axis. And Y bar will be 5.81 meter from y-axis. So this is the centroid of the wall. What we need to do next is we need to find the reaction. In order to do so, we need to get the loading that come from the wall. Kita kena cari dulu volume of the wall by multiplying the area with the thickness of the wall. We have the area of the wall 60.5 yang you dah calculate tadi. The total area times with the thickness of the wall 200 mm given in the question. So dekat sini saya convert it into meter bagi 1000. I get 12.1 meter cube as the total volume. And given the density of brick wall, dalam soalan dia bagi 1500 kg per meter cube. So you just times the density with the volume yang you kira for the wall Sebab 1 meter cube 1500 kg density. So kalau 12.1 kenalah darab dengan 12.1. I get 18,150 kg because this one kita pangkah So tinggal kilogram saja. And because of kita nak dia dalam force bukan mass kita nak dia supaya dia force ataupun weight ataupun load. Jadi kita kena darabkan dengan the gravity acceleration. You get this value which is equal to Newton lah. Kilogram meter per second power of 2 tu adalah sama dengan Newton Which is here I convert it into kilonewton bahagi dengan 1000 That is for the loading of the wall. Here I draw based on the loading of the wall and the centroid. Here is the centroid yang kita dapat tadi. The distance from the x-axis is 3.339 and the distance from y-axis is 5.81 meter. Next, we can find the value of RA and RB, which is the reactions yang soalan ni minta ya. I take the moment dekat support yang mana-mana antara A atau B. And in this case, I take dekat A. So first, we have one beam counterclockwise. You have another beam clockwise. Next, you have RB sendiri counterclockwise, and we have the wall load clockwise. Jadi kita akan ada 4 forces di sini. When I take moment at A, means that the total moment at A will be equal to 0, meaning equilibrium. Then the 6 kilonewton per meter times 4 times 2 meter is from the beam yang dekat kiri ni because this beam dia counter clockwise. So the load is 6 kilonewton per meter times the length of the beam is 4 meter, and from the centroid to A is 2 meter. Therefore, dia jadi macam ni, and negative because of counterclockwise. Next, we have another side of the beam at the right, which is this one is clockwise. 6 kilonewton per meter times the length of the beam. Kira sampai hujung because ini semua positif plus because of the clockwise So 5 campur 3 campur 3 campur 3 jadi 14 meter. And from the centroid to A should be half of that 14 meter, so 7 meter. It is 6 kilonewton per meter, and the plus because of clockwise times the length of the beam 14 meter, and distance from centroid is 7 meter. Next, we have the wall itself, which the load is 181.5 kilonewton. Clockwise, positive 181.5 kilonewton times the distance from the centroid to point A. It is 5.81 meter. So plus 181.5 kilonewton times 5.81 meter. And last kali, we have the reaction itself, which is RB. Going to A, this is counterclockwise. And the distance going to be 11 meter. So negative RB times 11 meter equal to 0. Then you can solve this and you will get RB is equal to 144.956 kilonewton. When we finally get the value of RB, we can get the value of RA using the force equation. So total force y-axis is equal to 0. We have RA going up. We have the loading from the beam. We have the loading from the wall. And we have RB. So this is RA and loading from the beam because of 6 kilonewton for every meter. And since the beam length total dia ni adalah 18 meter 4 plus 5 plus 3 plus 3 plus 3 meter. Tak perlu nak bahagi 2 lagi sebab dia bukannya arah yang berbeza macam kita buat untuk moment. Sebab semua force, this is force equation, so arah dia memang turun ke bawah sebab dia adalah loading ya. So 6 kN per meter darab dengan 18 meter going down. So minus lah. Then we have the load from the wall 181.5 kN. Dia adalah point load sebab kita dah kira untuk keseluruhan wall tu. And plus dengan RB. Replace the value of RB yang kita dapat dekat atas ni and get the value of RA here, which is 144.544 kilonewton. So that would be all for example number 5. Thank you and have a nice day.